Hi, good day everyone. So today we're going to be doing January 2024 number 7, which is typically a sequence question, right? They said the diagram below shows the first three shapes, right? The first one has 3, then, yeah. First three shapes in a sequence which forms a pattern. Each shape is made using a set of small white squares and black counters, right? They said complete the diagram which represents shape 4, right? So if you look, we know that shape 1 is 1, 2, 3, and we're going 2 up. This is 1, 2, 3, 4, 5. So add in 2, and we're going up 1. We're looking at the white, right? So if we look at the vertical and the horizontal is actually this. The horizontal was 3, the vertical was 2. Horizontal here was 1, 2, 3, 4, 5 was 5. The vertical was 3. So you can see that your vertical is actually increasing by 2. Let's make sure 1, 2, 3, 4, 5, 6, 7. So we can see that this is 7, and this would only increase by 1. 1, 2, 3, 4. Right? So if we're looking at shape 4, it should increase by 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So let's see 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're supposed to increase 1 up, right? So this was 4. So if this is the fourth, it's supposed to increase here. So we're going to add this 1, 2, 1, 2, 1, 2, right? And then we have increased by 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And then we're going to just fill in. These are the colored ones. Right. Draw here and draw here. And draw here, draw here. Draw here, draw here. And then draw here. This is how it's supposed to look. Right now, again, this is not something I could teach you. It's something that you'll have to recognize the pattern for yourself. But usually you just see how much it is increasing by, right? Or even the black dots, you can see it's decreasing by, so this was 3, and then this was 1, so it had decreased by 2. This was 1, 2, 3, 4, 5, and this is 3, so it decreased by 2 for each one. So if this is 9, this here is supposed to be 9 minus 2, that's 7. 1, 2, 3, 4, 5, 6, 7. 7 minus 2 is 5. 1, 2, 3, 4, 5. 5 minus 2, 1, 2, 3. And 3 minus 2 is 1. So that is how you could also just check the black. All right? So we white the horizontal. That is the one that's across was increases by 2. The white vertical increases by 1, right? The black, we can see that it decreases, or if you're looking at it going upwards, it decreases by 2. Right, so if you count from the last one, and you can see that it decreases by 2 as it goes up. Decrease by 2 as it goes up. Right? That's how I could probably teach you. But you can need to, I mean, from this you could recognize the pattern, right? And that here is 2 marks. Right, now let's look at this. The number of white counters W and the number of black counters B. So this is white and this is black. And the total number of counters T form each shape following a pattern. The values of, so this here is basically black plus white, all right? The values of W and B and T for the first three shapes are shown. Study the pattern in each row of the table and answer the question that follows. So we want 1, 2, and 3. So what you're going to do is you're going to look at these via terms. So this is your first term, this is the second term, this is the third term, fourth, fifth, and well, the answer is the answer. All right, let me right. So we know that this is your S. So you always compare your shape number with this. Right? So if we look at counter W, we have a first term. Right? The first terms is 1, 2, 3, and you compare it with the shape number. So you know your first term here is your shape number, or your term n is also equals to n, right? Your term, that is these down here, is 1, 1, 1. So you know it's a constant. Your second term is a constant of 1, Your third term, if you look at it, it's 2, 2, 2, right? So it's 2, 2, 2. You see that it's a constant of 2. Your fourth term, right? That is these 1, 2, 3, is also your shape numbers, right? 1, 2, and 3 is your shape numbers, or n. And your fifth term is equal to 1, 1, 1. So it's a constant of 1. Right? And then this is for counter W. Now, if you're looking for counter B, let's do the working right here. Counter B, you see that it's the first term is actually your counter numbers, right? So your first term is 1, 2, so that's your first terms, is your shape numbers. And your second term is equal to 1, 1, 1, so that is your constant, is equal to 1. Right? And then, well, T is you just add the 2. Right? Now that we know this is going to be easier to do. Okay, guys? So we know that when your shape number is equal to n, looking at this, when your shape number is equals to n, this would be n. Your second term is a constant, so it's n plus 1. Let me just fix this up. This, yeah, n plus 1, right? This one here is supposed to be 2 by n, or 2n, I should say, right? Because if you look at it, it has, this is supposed to be 2n, and this here would be 1. That's the last term. So this would be the formula for n, and then again, your first term is n and your second term is 1. And if we add all of this up, if you multiply, you'll get this. Now this one, because we know what is the shape number, this is very easy to do, right? This would be, we know that our first term is our shape number. So 4 plus 1 all squared is equals to 25. And if you, this is actually square numbers, right? 4, 9, 16, 25. All right? And then after that, to get this would be, remember they told you that the total number of counters is just you add the black and white. So this would be 45 plus 25, 5 and 5, 10, 4, 5, 6, so this is 60. And that is the answer for part 1. Part 2 now. Part 2, right. How do we do part 2? You use the formulas that you have here to go back. Now, if you look at this, I could tell you that the answer for this here is, they said that this would have been, I told you that this is square numbers. The square root of 144 is 12. So we know that it would have been 12 squared, right? And if we know anything about it, remember, this was something plus 1. So what plus 1 all squared? This would be 11. And this 11 is our 2. So from here, you would work backwards, right? Let's work backwards here. You're going to use your formula, n plus 1 all squared is equals to 144. You're trying to find n, which is basically your shape number, yeah? You first carry across the squared. What is the opposite of squared? N plus 1 is equals to the square root of 144. So n plus 1 is equal to 12. And then n would be carry across plus 1. So that's 12 minus 1. So n is equals to 11. So we know our shape number is 11. And because we know the shape number is 11, this would be, now there are two ways to do this. You could say, to get an answer here, you could just say 420 minus 144, right? And 420 minus 144 would be 420 minus 144 is equals to 272. How did I get that? Remember, to get this total number of counters, we add white counters plus the black counters. So 144 plus some value would give you 420, and that some value is 276. If you want it in this form here, you simply use this. You know now n is equals to 11. So it would be 11 plus 1 in brackets, square bracket here, that would be 2 times n, 2 times 11, we'll leave it like that, 2 times 11, close bracket, plus 1, square bracket here, and that would be how you would get, if you want it in this form here, that is this, or if you want the value. And even if you do this, you could probably check to see 11 plus 1 is 12, 12 multiplied by 22 plus 1 is 23. So 12 by 23 is 276, so you know that your answer is correct. If you multiply this out and multiply out the brackets, you're going to get 276, right? And that is how the expression of the total number of counters T is equals to W plus B in the shape S is given by total is A to the power of S squared plus B to the power of S plus 2, where A and B are both positive integers. By substituting the values of S, show that the total number of counters in shape 1 and shape 3 in terms of A and B is represented by the equation like this. So if S is your shape numbers, then we know that for shape 1, B is equals to A to the power of S squared plus BS plus 2. So T would be equals to A to the power of, what is S? Shape number is 1, so that's A to the power of 1 squared plus B to the power of 1 plus 2. Thus T is equals to A plus B plus 2. So if we look at what was the total for shape numbers 10, right? For so shape 1, T was equals to 10. Sorry, T was equals to 10 and S was equals to 1. So you just substitute it into the formula. So you're going to put this here, equals to 10, equal to 10, right? We want A and B by itself, so you carry across 2. So you know that's A plus B is equals to 10 minus 2. So A plus B is equals to 8. So you show this. Right? For shape 3, S is equals to 3, and using the table that we have here, what was the total? For shape 3, your total was 44. Right? T is equals to 44. You are going to put it in the formula here. So we have the formula T is equals to A to the power of S squared plus BS plus 2. So that's 44 is equal to A to the power of 3 squared plus B to the power of 3 plus 2. Yeah. Right, so that's 44 is equals to 9A, because 3 3s are 9, plus 3B plus 2. You carry across that 2 there, that's 44 minus 2 is 42. So you know that it's 42 equals to 9A plus 3B. However, we want B. So what they did is divide this entire thing by 3. So 42 divided by 3 is equals to 9A. Just now, let me just shape the is 9A divided by 3 plus 3B divided by 3. 42 divided by 3 is equals to 14. Is equals to 3 into 9 is 3A plus B. So we have shown that these are the formulas, these are the equations we will get for shape 1 as well as shape 3. And that is the end of January 2024, number 7.